Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 17 letter combinations of a phone number. So given a string containing digits from 2 to 9 inclusive, we have to return all possible letter combinations that the number could represent. And we can return the answer in any order. So the mapping of the numbers or the digits to the letters is given in the problem, and for example we have to map them. So 2 might be mapped to a string containing A, B, and C, and then 3 is going to be mapped to, let's say, D, E, F, and this continues until 9, which is mapped to W, X, Y, Z. So this is the mapping, and we can actually just use a dictionary. Since it's only the digits from 2 to 9, we can actually just create this hash map by hand. Okay, let's consider the digit string 2, 3. Then we have to take a look at each individual digit and see which letters it can map to. So first we take a look at 2, and 2 can map to 3 different letters, so it can either be A, B, or C. So let's create a decision tree, and we'll have 3 possible decisions for the first digit. We can have an A, we can have a B, and we can have a C. So for the digit 3, we have 3 options, D, E, or F, and that means we have 3 decisions. So for each decision, we'll have 3 more. And then this will be D, E, F, D, E, F, D, E, F. And then we'll get some strings, let's say A, D, and this will be B, E, and this will be C, F. So you can see that each of these paths is one of the possibilities. So this is AE, and this is BD, and these are all options that we can take. And we know when we reach the length matching the digits length, since each digit can only map to one letter at a time, we know that we're done recursing, so we can return back. So the time complexity of this algorithm is going to be big O 4 to the n. And the reason we have 4 here is because some of the digits like 9 have 4 possible letters that they can map to, so we need to take the worst case into account, and then the n is the number of digits in the string. So the space complexity is big O of n for the recursive stack as well as the resulting array that we're returning. So with that being said, we can go ahead and write the code on LeetCode. Okay, we're on LeetCode, and we can start writing the approach or algorithm. So we'll begin with the resulting array, and we know that this is what we're going to return, and this is going to have all of the combinations for the digits that are mapped to each of the characters or letters. Then we need to create the hash map with all the mappings. So I'll call this digit to character, and it's going to be a hash map with digits from 2 to 9 that are mapped to some particular letters. Okay, now that we have the hash map, we can start writing the backtracking method, and we'll just call this backtrack. What we're going to do is we're going to maintain a index pointer to the digits that we're on. So let's say we have 2, 3. We want the ith pointer to keep track of where we are in the digits. So this is going to be I. and the path, which is going to be the possibilities. So for 2, 3, we can have something like AD as a path. Then what we want to do is we want to write the base case, and as we discussed, the base case is exactly when the length of the path is equal to the length of the digits, or we can just say that I is equal to the length of the digits. So if I is equal to the length of the digits, then we want to append the path into the results, and we want to return. So this is leaving the recursion, and if it's not equal to the length, or the path is not equal to the length of the digits, then we want to keep recursing. And the way we do that is we're going to get each of the characters in the map, and we can say digits I. So basically what this means is we're looking, let's say, at some digits, and we're taking all of its possible letter mappings and looping through them. And for each character that is possible, we want to backtrack. And we want to increase the I pointer by 1. So this means we've added some character to the path, as well as actually adding the character to the path string. And finally, we have to take care of some base cases. So we know that if digits is empty, we're just going to return the empty array. So we can just write if digits, then we want to backtrack. And we're passing in 0 for the 0th index and an empty string for the path. And this should be the entirety of the code. So we can go ahead and submit it. And as you can see, the code is accepted, and it is the optimal solution. And this is running in big O of 4 to the n time with a space complexity of big O of n. So hopefully this video was helpful and you learned something, and I'll see you soon.